Hi everybody, this is Mr. Kestel. This is the last video of this four-part series on electricity and all the different components and parts about it. This video is on power and batteries. Okay, something else that we often hear and think about when we talk about electricity is this term power. So I'm going to write that down here, power. And in physics, it has a specific meaning. And when we're talking about electricity, it has a specific meaning. So power is equal to the electric energy divided by time. And so this is very similar to if you watched the video about work and power there. We said power is equal to joules divided by seconds. Okay? And so joules is the unit for energy, seconds is the unit for time. And so when we talk about power, we measure it in what we call watts. Watt? Sorry, I couldn't resist. Okay, so watts. Be very glad that you're not here with me, or I'm not with you teaching this at school, because whenever I would be constantly asking you watt, and you'd get really annoyed. Anywho, so power is measured in watts, which is just joules per second, or the amount of electric energy per time. You can sometimes rearrange that if you need to. If you need to know the amount of energy, you can say that that is equal to power times time. Okay, so this statement, power equals electric energy divided by time, and this statement, electric energy equals power times time, those two are telling you the same thing. You're just kind of rearranging the variables. Okay, so if you're dealing with the electric company, or also like big appliances and that sort of thing, they will use a different sort of unit, which is called a kilowatt hour. So kilowatt hour. So 1 kilowatt hour, let's break this down what this means. A kilo is 1,000. So if we say 1 kilowatt, that would be 1,000 watts in 1 hour. Okay, so you could say, or you could say 1,000 watts in 60 minutes, or you could say it in 3,600 seconds. But we're just going to go with 1 hour. Okay. Okay, so where is this useful? Again, electric companies and appliances look at the power that you either use or are needed to operate. So appliances use power ratings to tell the watts needed to operate it. Okay. Also, the electric company will measure how much electricity you use in watts. They use power. So how could we figure out how much power there is? How much power we're using, or a device uses? Well, power comes from the amount of current flowing through something times the voltage. Okay? And so if we look at this battery here, there's this light bulb has a certain brightness, okay? And the battery, where usually most batteries have, we're going to say 1.5 volts, okay? Which you can see that's not using there's not much power here. And so because the voltage is low, and so you can see the electrons are not flowing very quickly, so there's not very much current. If we increase the voltage, boom, look at how fast the current's flowing. It's going a lot faster, and the voltage is a lot bigger. So that's going to use more power. So if you have a lot of appliances hooked up, if you've got your TV running on 24/7 all day long, every day of the week, then you may have the same amount of voltage, but the current running through it over time, that's going to be a lot of current that's running through it. So that just really quick example of how we use voltage, where that power comes from. Okay, unfortunately, we're almost reaching the end of our time together. There's one last thing I'm going to talk about. We used batteries in our example here, and I just told you that most batteries have 1.5 volts. Okay, well, there's a couple different kinds of batteries that you can have. So, batteries. You can have, there's two basic types. You can have a dry cell, which are the portable batteries. They use a paste inside of them. And we use them in flashlights, all sorts of things. Anything that Xbox controllers, anything that you've got, there's AA, AAA, D cell, C cell, those are all dry cell batteries. Now, a car battery is a different type of battery. This is called a wet cell. This has got an acid solution inside the battery. So this is used in cars. So these are a dry cell battery is pretty safe as long as you don't open it up. If it gets broken or something like that, punctured, nothing's going to flow out of it. You're probably going to be okay. You can throw it away. A wet cell battery is much more dangerous. Inside the battery is sulfuric acid, which can definitely be dangerous. You can use the car battery acid in chemistry. I actually did that as a chemistry teacher. One time I ran out of sulfuric acid. I wasn't going to be able to get enough sulfuric acid for a lab, so I just used car battery acid, and it worked just fine. I don't recommend that you do that because it's dangerous, but it is something you can do. So I hope this was as exciting and fun for you as it was for me. I hope you have a wonderful day full of laughter and joy, and feel free to get in contact with me if you have any questions.